Hi all, good morning. Today I am going to discuss about electric potential due to a point charge. This topic will come under chapter 2 for grade 12 physics. Okay. So first I am going to draw the diagram for this concept. Consider a point charge plus Q at O. Consider a point charge plus Q at O. Okay. Then consider a point P at a distance R from O. Next, after considering the point charge plus Q, that is the source charge plus Q at O, you have to consider a point P at a distance R from the center O. Hope it's clear. Okay. So now what I have to do? I am drawing a closed surface like this because according to Gauss's law, the charge should be enclosed within a closed surface. Okay. So for a point charge, here I am drawing a sphere. Okay. So I have considered the source charge. Next I am going to consider the test charge. Source charge I name it as plus Q and test charge I am going to name it as plus Q naught. Okay. Plus Q naught at infinity, at a far off place. Okay. So here I am going to consider two more points named A and B. Okay. And the distance between A to the center O is x. Distance between this point A to the center O is x. So I am connecting these 2 points. Okay, since it's an infinity, far off place, I am drawing that through straight lines. Okay, since it's a far off place. So as I told, the distance between the center O to A is x. Okay. So now what should I do? I have to find electric potential at this point P. What I have to determine? I have to find electric potential due to a point charge at this point P. Okay. So from our definition itself we know electric potential is the work done in bringing a unit positive test charge from infinity to a point P. Am I right? So I am writing it in formula form. Okay. So V is equal to W by Q. Okay. Q naught. Let it be the point charge. So electric potential represented by V is the work done in bringing a unit positive test charge from infinity to a point P. Okay. So let this formula we can block it and consider throughout our derivation. Okay. So now what I have to do? Here we are bringing the positive test charge from infinity to a point A. Now we brought it to this point A. Okay. So now the test charge is at point A. What I should do? I should again do some work to bring this unit positive test charge from A to B. From A to B. So if the unit positive test charge is brought from A to B, let this small displacement be dx. Let this small displacement be dx. Okay. So now here we are doing some work by bringing this unit positive test charge plus Q naught from A to B, and the displacement we are mentioning it as, since a small displacement, it's dx. Okay. Hope it's clear. Okay. Now I am going to write the work done. Work done is equal to, if you see here, since it's positive charge, this is also positive test charge, this is also positive source charge. So the force will act outwards. The force will act outwards. Since both are like charges, they will repel each other. So the electrostatic force F will act outwards. So I am doing some work in bringing the unit positive discharge from A to B. So from A to B I am bringing, and the force is acting to my right, and I am bringing the discharge from right to left. If you see, work done is opposite to this force. The direction of work done is opposite to the direction of force. Okay. So W is equal to F into dx. That is our common formula. MNA. Since here work is done opposite to the direction of force, I am writing it as here theta is equal to 180 degree. Okay. So I am writing it as F dx cos theta. Why it's cos theta? Because it's normal horizontal component. Okay. So since theta is 180 degree, cos 180 is minus 1. Cos 180 is minus 1. Okay. So it will become minus F into dx. Dot product. Okay. It's a dot product. W is equal to minus F into dx. Okay. Let me do the derivation in our next video, part 2. Okay. Thank you.